Last time we learned you can borrow values with immutable references, which is read only and safe. But what if you need to actually change the value? That's where mutable references come in. Let's do a quick recap. Immutable references are read only. You can have as many as you want, but you can't modify the value through them. If you need to modify a borrowed value, you use a mutable reference. It's written as &mut. This tells the compiler that I need write access, not just read access. So let's see this in action. First of all, we declared s as mutable. Then, we pass a mutable reference to the change function. Inside the function, we can now modify the value, and when we print s back in the main, the change persists. But here's where Rust gets strict. You can have only one mutable reference to a value at a time. Let's see what happens when you try to create two. See, Rust compiler throws error saying that cannot borrow s as mutable reference more than once at a time. Why does Rust do this? The reason behind this is data races. If two parts of your code could modify the same value at the same time, then that will cause chaos. Rust prevents this at compile time. One writer at a time or many readers, but never both simultaneously. But here's what you can do for having multiple mutable references. This is where scopes become powerful. Once R1 goes out of scope and stops existing, R2 can safely be created. No overlap means no conflict, and the compiler is perfectly happy with that. So Rust says that you can have mutable references, but only one at a time. This is how Rust prevents data races at compile time. Next up, the final piece, dangling references and lifetimes. Follow us so that you won't miss it.